Hello student. In this lecture, we are going to extend our discussion for general solution of a trigonometric equation. So far, we come to know how to write down general solution for equation like sine theta equals to some particular values only. These values were 0, positive 1 and negative 1. But now I wonder how would we write down the solution for more equation. Likewise, sine theta equals to 1 by 3, it can be 1 by root 2 or anything. So for that one, I'm going to generalize the solution for this equation, and its solution is usually given by the formula theta equals to n pi plus negative 1 to the power n alpha. Now I have two questions. First, how did I get this solution? Second one is that what will be the values of alpha? Say if you want, if there is any solution for particular equation, let me write down the equation. So say we have sine theta equals to k. Solution will exist only when the values of k is in that range from negative 1 to positive 1. That means there will definitely be an angle alpha corresponding to sine, which will give you particular value k. Say we have a particular angle alpha is there, then to get these general solution, what I need to do, I need to bring this term of sine alpha to the left hand side of this expression. Then I have sine theta minus sine alpha is equals to 0. Now you should be good with your sum and difference of trigonometric identities. What sine C minus sine D stand for? It is 2 cosine C plus D by 2 times sine C minus D by 2. Sine C minus D by 2. By that way, we have product of two trigonometric function result in a 0. That means either cosine theta plus alpha by 2, it should be turned to a 0, or your sine theta minus alpha by 2 must be equals to 0. Now, if I try to solve cosine theta plus alpha by 2 equals to 0, I end up getting alpha theta plus alpha by 2 equals to n pi plus pi by 2, which is basically the general solution for cosine some angle equals to 0. Similarly, corresponding to sine, I will write general solution as theta minus alpha by 2 is equals to m pi. Now let's have a look on the first solution from first expression. It is theta is equals to odd multiple of pi, odd multiple of pi minus alpha. Am I right? And from the second expression, I'm getting even multiple of pi, even multiple of pi plus alpha. Your m and n, which are arbitrary constant, can be any integral value. Now this general solution which I mentioned on top of the screen, so, how would I read this expression? Here, n is any integral value. The moment I put any even values, I end up getting solution from expression number 2. Remember, for any even values of n. Now, if I try to put any odd values of n, I'll end up getting solution from expression number 1. So, rather than remembering two different expression, I would say just learn this one, n pi plus minus 1 to the power n alpha. Now the second question is that what should be the value of alpha? Because alpha can be any value. Now if you want to be very specific, then about the values of alpha, just have a look on the graph of sine. In that graph, I'm picking this branch from negative pi by 2 up till positive pi by 2. In that specific range, your sine function is 1 1 as well as on 2. Function is increasing. That means for any specific value of alpha, I'll get a specific value of k only. No two values of alpha will yield the same result. And another reason is that that particular branch is very close to origin. Thereby this branch alpha from negative pi by 2 to positive pi by 2 is also known as principal branch for sine function. Principal branch of sine function. Let's try to solve a question. Say I need to get general values of theta for which sine theta is equals to negative 1 by root 2. First of all, I need to find out particular value of theta for which I'll get a negative 1 by 2 response from sine. I know sine pi by 4 is actually equals to 1 by root 2. 1 by root 2. The moment I replace this pi by 4 with negative pi by 4, result will be equals to negative times sine pi by 4. That is what? That will give me negative 1 by root 2. Now here I find out the value of alpha. It is negative pi by 4. So let me write this expression again. Sine theta is equals to sine negative pi by 4. Half of the work is what we have done so far. Now the next thing is that to generalize this expression using the formula n pi plus negative 1 to the power n times alpha. Here your alpha is negative pi by 4. This is how do we write down the principles, the general solution for sine theta equals to negative 1 by root 2. Say if I need to find out its principal solution, that means allotted range for theta is from 0 to 2 pi only. So once I write down the general solution, I need to put different values of n to get different response corresponding to theta. For example, if I put n equals to 0, I'll get theta equals to negative pi by 4. Correct? For n equals to 1, I'll get theta is equals to pi plus pi by 4. And now for n equals to 2, I'll get theta equals to 2 pi 2 pi minus pi by 4. Now I don't need to put different or further values of n. Why? Because this is the allotted range. If I put 3 or any other value of n, it will be beyond our range. Theta negative pi by 4 is not acceptable. So the only principal solution is pi plus pi by 4 and 2 pi minus pi by 4. I'm sure you understand how to use the formula for whenever we have some particular alpha angle is there. So this thing can be generalized for other result. Say this time I need to find the general solution for cosine term right there. So question would be, it would look like cosine theta equals to k. It is equals to k, where k can be any real values in allotted range from negative 1 to positive 1. So to solve this question, I'm sure then particular alpha angle will be responsible for that particular value k. So I replace that k with cosine alpha. And the next step, I'll be bringing this cosine alpha to left hand side of this expression. Now I have cosine theta minus cosine alpha is equals to 0. I have to use what cosine C minus cosine D stand for. It is negative 2 times sine theta plus alpha by 2 times sine theta minus alpha by 2. This is equals to 0. Again, we are on the same track. Product of two trigonometric function is equals to 0. That means two possibilities are there. Either sine theta plus alpha by 2 will give you a 0, or sine theta minus alpha by 2, should be equals to 0. Do try to write its general solution. For sine theta plus alpha by 2, you should have theta plus alpha by 2 equals to some k pi, or let me use some other symbol that time. Let's say we have some p times pi. Similarly, for theta minus alpha by 2, let me choose some other symbol this time. We have q pi. So there we have two different values of theta. Theta, either it can be 2p pi minus alpha, or either your theta may be 2q pi plus alpha. And collectively, we may write their solution as 2n pi plus or minus alpha, where these arbitrary constant p, q, and n, they belongs to integral only. But what about alpha? For the values of alpha, again, we have to choose that branch which is close to 0, as well as which will give you unique values of theta. No two angles should responsible for a value. And theta from 0 to pi will give you that opportunity where particular angle will responsible for particular value. So that being your principal value branch. Correct. So this time we will not be entertaining negative pi by 2 to pi by 2. Otherwise we will not get any negative response. Say if cosine theta equals to negative 1 by 2 is for that one we are searching for general solution, then this range is not sufficient to give your desired solution. Now let me take a question. We have a question with the where different types of angle are participating. 5 cosine 2 theta is there, and 2 times cosine square theta by 2 is there. So is there any way we can convert their argument in in same argument? Say I'm using multiple in some multiple approach where I can write cosine 2 theta as a 2 cosine square theta minus 1. And this 2 cosine square theta next term can be written as 1 plus cosine 2 times theta by 2. Am I right? What I'm trying to do there, I'm just trying to bridge this gap between their argument. Now everything look fine because we only have to deal with cosine theta. So we have 10 cosine square theta plus cosine theta minus 3 is equals to 0. Try to factorize this expression if you can. The factor will be 6 and 5. We have 6 cosine minus 5 cosine minus 3 is equals to 0. Then we have 2 cosine negative 1 times 5 cosine plus 3. It is equals to 0. It will attract two different values or two different expression. One is cosine equals to 1 by 2 and another one is cosine equals to negative 3 by 5. For 1 by 2, we all are aware with that particular angle in principal range. So for cosine equals to 1 by 2, one may write down the general solution as 2n pi plus or minus pi by 3. But so far in maths, we don't know what angle is responsible for negative 3 by 5. So if you struck at such kind of problem, you need to mention in a side that there will definitely be an angle alpha in principal value branch where cosine alpha will give you negative 5 by 3, and you may generalize your solution there. Theta will be equals to 2k pi plus or minus alpha, where cosine alpha is equals to negative 3 by 5. I'm sure you get it how to write down the general solution for sine as well as for cosine angles. Thank you very much.